Good morning. We're going to separate again into two videos. The first one is for the homework. This is going to take a fair amount of time. I will post it with the answers. I also posted a link yesterday for the Tyler DeWitt explanation of voltaic cells. It is kind of long, but he does a very nice job, and I've already gotten feedback that it does work pretty well. So this is the second to last concept that we have before our test, which will be on Thursday. So we'll have another concept today. It will not be heavily weighted at all, really, for your test, but I do want to introduce it to you. Okay, so here we have an electrochemical cell, and that V right there indicates a voltmeter. That can measure how much electricity is flowing through it. So one of the big differences between voltaic or galvanic cells and electrolytic cells is that we're going to have two containers. The other thing that's different is we have two flow. One, we have an electron flow, and then we have the flow of ions. Okay? So we have to do that in order to keep the charge the same. So what's our setup look like? Both of these containers have nitrate, and I've got aluminum strip here of metal and a lead strip of metal over here. Remember that when we have ionically bonded substances that go into solution, they dissociate. So what you're seeing here is showing the solution, but it's actually aluminum 3+ and nitrate minus. Over here we have lead, and hopefully you can see that that's lead 2, because that's where that 2 came from, so it's a positive 2. And again we have nitrate, NO3 minus. Okay, so let's see what's happening here. I've got aluminum and I've got lead. So I've got to compare these two as far as the reactivity of them to see which one's going to get oxidized and which one gets reduced. So I'm going to open my CRT up to table J. And find aluminum and find lead. Well, here's aluminum and here's lead. So that means aluminum is above lead on the reactivity series, the activity series. So that means aluminum is more likely to get oxidized. And when it loses those electrons, lead gets reduced. So in my setup here, I've got aluminum being oxidized, which is the more easily oxidized metal, aluminum or lead. So this is aluminum. And what is the balanced equation showing the spontaneous reaction that occurs? So let's do the half reactions first, because this will be a good practice for us. So I'm going to move this up to make it a little bit, give us a little bit more space down there. So over in the top left-hand corner here, I'm going to put what this reaction is. Okay, so we've got aluminum. Aluminum is going to get oxidized because it was above lead. So we're starting as a solid. It loses electrons and becomes aluminum 3+. See that 3 comes from the aluminum? And in order for me to even this out, this is going to be 3 electrons. Okay? What happens on the other side? We've got lead here. We've got lead. And as we said, lead is going to gain electrons. So we make lead 2+. So in order for that to happen, we're going to have to gain electrons. Oops, I put the wrong thing here. Lead is not a solid here. Lead, this is the lead 2+. It's going to gain electrons in order to become lead solid. So how many electrons is it going to gain? It's going to gain 2 electrons. So if you're looking carefully, you can see that there are 2 electrons here, but 3 here. So when we go and put the reaction here, we're going to have to do some multiplication to make sure that these 2 electron numbers are the same. So I'm going to do it up here, even though normally we would put one on top of the other. Actually, I'll put it right. I'll multiply them up there, and then we'll put a sum down at the bottom. So we're going to multiply, we've got 3 here and 2 here. So in order to get them both the same, I'm going to multiply this one by 2. I'm going to multiply this one by 3. So now I can rewrite them. So I multiply everything in here by 2. So I've got 2 aluminums yield 2 aluminum plus 3s, and 2 times 3 is 6. Over here, I've got 3 leads, ions. 3 times 2 is 6. And 3 times just lead is 3 leads. Now I'm going to combine them, and I'll put that down here. Okay, so what do we have? We've got, I'm going to bring the aluminum down. 2 aluminum yields 2 aluminum 3+ plus 6 electrons. Then I've got lead, 3 lead, 2 pluses, plus 6 electrons, yields 3 lead solid. Okay, now I can take care of my electrons. We have to have the same number of electrons in both. And what's my sum? And that's going to be my answer here. I'll make that one in green. So my final answer here is 2 aluminums plus 3 leads yields 2 aluminum plus 3 leads. Okay, let's check it for both charge and number of atoms. 2 aluminums, 3 leads, 3 leads. Over here I've got a total of 0 charge plus positive 6. So positive 6 on the reactant side. Positive 6 plus 0. So I've got a positive 6 over here, positive 6 over here. Okay, that's my answer. Okay, so this is spontaneous. Why is it spontaneous? Because aluminum is more reactive than lead. That means the electrons are going to flow. Okay, so what is the direction of flow in the wire? Well, if aluminum loses electrons, the electrons are going to leave the metal, travel through the wire. It's going to register on the voltmeter. There's a little, not a wire, it's an indicator here that moves back and forth depending on how many electrons are coming through here. The electrons will continue to flow here and then end up at the lead itself. Okay, so there's the direction. Let's do some more labeling here, because we do have to label this and know what's going on. So oxidation happens at the anode. Remember an-ox and red cat. The other mnemonic device that I want you to remember, and we'll hit it again today, is van. Van is the mnemonic that says in a voltaic cell, the anode is negative. Okay, so this is a voltaic cell. It happens spontaneously. So the aluminum is the anode. It is negative. What always happens at the anode is oxidation. So over here we have the cathode. The cathode in this case is going to be positive. And this, where the cathode is, reduction always happens. Okay, so we can see that the reduction on this side is happening here, and the oxidation is happening here. So what is the direction of the flow? It's from aluminum to lead. In other words, it's always from the anode to the cathode. And the way to remember that is it's alphabetical. In other words, from A to C. Always. Okay, number 4. What is the direction of positive ion flow in the salt bridge? Okay, another idea here we've got to have. So let's take a look at what's happening inside these solutions here. Okay, as the aluminum loses electrons, what happens? So here's the aluminum. It's losing electrons, and it's forming this, aluminum ions. So the concentration of this is going up, yes? Now I have a set amount of aluminum nitrate in here. So if I keep forming aluminum 3+ by the aluminum metal, solid metal, turning into aluminum 3+, then this is going to start to break down. It's going to deteriorate. We're going to see that that starts to disintegrate. And what happens here is that these aluminum 3+ are going to start to end up in my solution, and my charge is going to become more positive in this solution. Now if we look over here, what's happening over here? The electrons are flowing through, and when they get to the lead is going to gain these electrons. So when the electrons arrive at the electrode, these ions, right here, same ones, are going to pick up the electrons from the aluminum, and they're going to start to form lead solid. And that lead solid is going to form on the outside of the electrode. So this one is going to actually gain mass here. So if that's true, what's happening to the concentration of the lead 2+? Well, isn't it getting converted into the lead that's going to coat this electrode? So what's happening to the concentration of the of the lead 2+? It's going to go down. And if this becomes less of it, we're losing positives. That means it's going to become more negative, because these aren't really going anywhere yet. Okay, so this side gets more positive because of the buildup of aluminum 3+. This side gets more negative because we're losing the positive ions of the lead 2+ to form lead solid on the electrode. So that's why we have to have what this salt bridge is called here. This salt bridge allows for the flow of the NO3. So what's going to happen here? If this side is more negative and this side is more positive, this side wants to get rid of, wants to allow for the flow of the aluminum to get rid of the positivity of it, yes? So if this is 2 positive and I'm forming aluminum 3+, the aluminum, I'll make it green, the aluminum is going to travel up through this tube. It's actually just a tube. And it's going to flow through here. So the aluminum is going to go in this direction. And what's going to happen to the NO3? Since this is more negative, the negative wants to get away from the other negatives. So the NO3 is going to travel up through the tube. So NO3 goes this way. Okay? So what is the direction of positive ion flow in the salt bridge? It's going to go from the aluminum side, to the lead side. That way it's going to even it out. If we didn't have this salt bridge here, this would just get more and more positive to the point where the electrons wouldn't want to leave because they would be attracted to the positivity of the aluminum. Okay? And the opposite would be true here. Eventually there would be so much difference in charge that there wouldn't be any movement of the electrons. Okay, which electrode is decreasing in size? Well, we just saw that. We explained that one. That's aluminum. Which electrode is increasing in size? That's lead. What is happening to the concentration of aluminum ions? So aluminum, because of this half reaction, we're increasing the concentration. What's happening in the concentration of lead ions? The lead ions in solution are going through this reaction, so they're getting converted into solid lead. So that's decreasing. Number 9, what is the voltage in this cell when the reaction reaches equilibrium? We're gonna skip that one for now. Number 10, which is the anode? Well, we already labeled that one. Which is the cathode? That would be lead. And what is the positive electrode? Positive electrode, remember Van. Where's Van? Here it is. According to this in mnemonic, in the voltaic cell, which this is, the anode is negative. So the positive electrode is going to be the lead. That's the cathode. And lastly, what is the negative electrode? That's aluminum. Okay, we may come back to this in the lesson itself. All right? Probably should watch that because it's a good explanation, and you might not get it unless you look at the Tyler DeWitt video. See you soon.